Hello, everybody. Thank you so much for being here with us. This is our second intellectual property NFT ceremony, and we're very excited about it. My name is Laura Minkini. I'm the core lead of AthenaDAO. We're the leading decentralized science DAO working in transformative women's health research, education, and funding. I have with me Dr. Maria Marinova, our co-lead in science and deal flow, and Dr. Joshua Johnson, who is the researcher that we will be learning more about today on the intellectual property NFT that we actually already minted it. This ceremony is actually just symbolic, but we're going to learn more about his work, about the research, and why this could make a difference in women's health. We're going to start first with letting you know more about where we are at with AthenaDAO. I also want to take a moment to thank Ines Santos Silva, who is our core ops lead, who puts together these amazing events for us and powers everything behind the wall. So AthenaDAO was formed on August 2022. We already had our Genesis token auction, and we're very proud to announce that it was oversubscribed. We've minted 2 IP-NFTs so far on research and impacting ovarian aging. And we've had 80 project submissions in 2 cohorts, ovarian aging, PCOS, and endometriosis. This is very significant, as it means that a lot of people are interested in this kind of new funding mechanism. And more importantly, women's health research needs a lot of funding. Our DAO counts with 40 active contributors across different areas of work. There's science and deal flow, the most important. And while all the parts are important, but science and deal flow is really what matters in making sure that we're trying to search for this scientific research, the researchers and academic institutions that we could collaborate with. Comes in awareness, operations, legal and tokenomics. And we're very open to people coming and joining our DAO to actually proposing other channels and other areas of work that we could actually pushing forward women's health research. The other part is that we have 50,000 members across all channels, and we're the second biggest bio DAO after Vita DAO. I am going to now pass over things to Dr. Maria Marinova to make an introduction to Dr. Joshua Johnson. Maria?
Thanks, Laura. Very excited to be here. I'm Maria Marinova. A little bit about me. I did my studies in molecular biology. I did a PhD also in reproductive longevity, which is quite a new area. I also worked in VC and venture creation for a bit, and then went into DeSci. I want to share about the first round of application we ran from AthenaDAO. It was focused on ovarian aging and reproductive longevity, because we believe that is an extremely overlooked area of biotech, of women's health, and within the longevity field. Every woman would experience ovarian aging, decline in function, and senescence over time. And this happens very early on. At 35 years, your ovaries would already be considered geriatric, which leads to a very rapid decline in fertility, and ovarian function, ultimately leading to menopause. And that, of course, is not just a matter of fertility. Women's health is greatly impacted by menopause, and the risk of multiple diseases increases. So targeting ovarian aging is a matter of health span and women's longevity. So we're very proud to support Dr. Johnson's project, which focuses on the integrated stress response and how that affects follicle survival and growth within the ovary. So I want to pass it on to Joshua now.
Thanks very much, Maria and Laura. It's an enormous pleasure and with great pride being supported by AthenaDAO that I'm here today. And I'm excited to share 2 approaches that we take in my lab that led to the funding from the AthenaDAO. I'm originally from Wisconsin in the USA. I trained at the Mass General in Boston, followed by a stint on faculty at Yale School of Medicine and now at University of Colorado. From graduate school, I've been interested in ovarian aging and this unique system where separate units, ovarian follicles, decline over time, And I've been quite obsessed with the rules and physiology that dictate this process. So I have some slides for you this morning that I'll go through. I'm happy to take questions afterward. All of these relate directly to our funded work with AthenaDAO and our goal of slowing ovarian aging in women who are at risk for primary ovarian insufficiency. So I won't read a busy slide like this, but we focus on both the causes of ovarian aging and its consequences. What would we be rescuing if we could slow ovarian aging? There are genetic and environmental modifiers of the process. And there are also mechanisms that were established in the last, say, 30 years. And there's been a lot of wonderful progress in the last 5 to 8 years. And our contribution to this area is recognizing that this integrated stress response, a combinatorial or funnel pathway into protein translational control, significantly influences ovarian aging. So our goal is to target ovarian aging by targeting this ISR pathway and thereby improve women's health. My lab takes advantage of wet lab data. That's my own personal expertise. And we also collaborate with mathematicians and statistics professionals to see how we can use that to work backward and then re-inform our wet lab data. So why do ovaries fail when they do? It's because they run out of follicles. What mechanisms determine the known patterns of follicle growth activation, growth, and death? These combine to generate the pattern of loss of follicles. And these mechanisms determine the age of natural menopause when women run out of follicles. Here's what follicles look like in cartoon form. And my lab is focused on this first step, the transition between primordial and primary follicle development. That's when follicles are lost from the reserve. I like to look at it in a scheme like this. At its simplest, women can be born with 100,000 to 1 million ovarian follicles. And for reasons that had remained elusive, one might begin to grow in one corner of the ovary when a girl is 13 and another when she's in her 50s. And so getting our heads around mechanisms that control this interesting pattern has been difficult. Once they begin to grow, red here indicates that follicles are dying and a smaller fraction are growing and surviving. That continues as they get larger, continues further until about 1 mature follicle is around to ovulate each month, where its ovulated egg might be fertilized. These graphs just show the overall trajectory of follicle loss, and maybe the easier to understand graph is here in this Kaplan-Meier curve, showing the probability or proportion of women at advancing ages on the x-axis will reach menopause. And you can see the red line indicates the median age of 51. But I think we all can agree that the decline of ovarian follicles is massive and precipitous, and we're dropping from being born with between 100,000 and 1 million in women to around 1,000 at the time of menopause. So how is this controlled? And now consequences, we all know, and we're here to offset these health compromises. 1 in 250 women will experience menopause prior to age 35, 1 in 100 before 40. And all of the consequences of this listed on this slide are impactful, and all of us would like to help women avoid or improve these conditions. Maria mentioned ovarian aging is a critical determinant of health and lifespan. The earlier you reach menopause, the higher your risk of cardiovascular disease at left or stroke at the right. So keeping ovaries aging longer is likely to keep these benefits and these conditions delayed as well. Even life expectancy, I think Maria said this too, the earlier you hit menopause, the shorter your expected lifespan. And so for women who are at risk of early loss of ovarian function, there could even be extended lifespan benefits. Because IVF and ART is available today, increasing women have advanced warning. More women are getting indications their ovaries are aging more quickly than others. And this brings us to the strategy we're using, targeting the integrated stress response in the AthenaDAO funded project. In a collaboration with the University of Utah, we showed that mice that are galactosemic treated with a particular drug, salubrinol, we can slow their ovarian aging, we can increase with salubrinol the number of eggs they'll ovulate, and even increase litter size and on-growing litters from these mice. And that led us to the question, could this same treatment potentially slow ovarian aging in normal mice and then normal women? Salubrinol protects the survival of the primordial follicles I mentioned, those dormant follicles, and normalizes their rate of growth. And so by targeting this integrated stress response, it appears that we're not just manipulating follicles, but and keeping them alive, we're also helping them to behave normally. And quickly, not only salubrinol, but natural products in a screen by Sineva, Haag, and Lilovic showed that even a compound like purple sweet potato color we used can normalize ovarian aging and galactosemia. And bringing us to this integrated stress response, what is it? At its base, this translational initiator controls protein translation of stress-responsive target proteins. Once a cell is stressed, this integrated stress response increases the presence of proteins that resolve that stress. And we noted that the stress state is consistent with the non-growing primordial follicles, and we showed that the pathway is indeed on in dormant follicles. So what we need to do is actually enhance this stress state to keep follicles dormant and alive. We're targeting the normal ovary in this funded project and testing if this strategy will work in normal ovaries in mice and in human ovarian cortex. I'm going to skip this for the interest of time. This just shows you that indeed the pathway is on at baseline here in the circle in mouse ovarian follicles. Here are other markers of stress. It brought us to a model that we used to think about the problem, that normal follicles are here in this red zone where they're arrested and not growing. And it's when ISR activity becomes higher, they begin to grow. And again, we're targeting that in normal ovaries. So I'll wrap up by briefly mentioning our math collaborators. Here's Dr. Lowley at Utah and Jay Emerson at Yale. And with them, we've interrogated this interesting exponential loss process of follicles that occurs in mice and women. And we're taking advantage of this actually in our wet lab studies. What we're doing is we're flattening out this curve, and we're able to monitor that ovarian follicles are being depleted more and more slowly when we intervene. But with Jay and Sean, we've developed mathematical models that accurately recapitulate loss trajectories. You can see in dashed lines here are simulations of women losing their follicles over time in different circumstances. And if we compile the results of those simulations, we've published that you actually can get back out the human distribution of the age at natural menopause. We're also using this to interrogate the menopausal transition. So wrapping up, normal tissue function in women, this integrated stress pathway, response pathway is on. When cells undergo checkpoint recovery, this is the actual event that follicles begin to grow. And rarely they grow and survive such that that oocyte will get ovulated. And so right at the bottom of this slide, our combined wet lab and math projects hold the promise of revealing safe, impactful ways to slow ovarian follicle loss. And in this way, our math helps us understand ovarian aging. So thanks for your attention. And again, thank you to AthenaDAO for this chance to talk about what we have going. Thank you.
Thanks so much, Josh. That was a great overview. I want to start with the questions, but if anyone from the audience has a question as well, please put it in the chat. So I was wondering, what do you think would be the impact on women's lives if this project is successful and you can bring it forward? And also, would there be any specific subtypes of the population of patients that could benefit the most?
It's a great question. And the lucky thing is that the population that can be helped the most will know if we are helping them the fastest. And so women who are identified, whether using antral follicle count or AMH, which is less precise but useful, we can begin them on, I hope, a series of natural products that are known to regulate the integrated stress response. And a blind versus placebo-controlled study should show that ovarian functioning is ongoing in women who otherwise periods would become rapidly irregular and they'd hit menopause quite early. So in the best case, that can be done, and it's a rigorous process to do this, but in less than 5 years, you'll know if you have signal with some of your intervention compounds.
Great, thank you. Are there any other questions? I can't see anything new in the chat.
And of course, people can follow up with me. X or Twitter is fine. Email is fine. My email is on there too. And I just want to express my gratitude and in some ways amazement that we got through, given the number of applications you received and the quality that I know that they'll have had. So we're so excited to do the work.
Thank you, Josh. I think we're even more excited than you are. It's so important for us because people need to understand that every project that we fund is another opportunity to push women's health forward. And obviously, there are already academic institutions doing this for years and decades and foundations, but this is a new model. And everything counts because we want to remind everybody that women's health research is massively overlooked. And every opportunity matters. As little as $50,000 and $150,000. Hopefully, one day we can give much bigger grants or much bigger funding and also grants. So, hopefully, with this, we're going to find great IP assets and then continue our regenerative model. But to talk more about the future of IP-NFTs and why they are important and the innovation in them, I'm very happy to have as a special guest Vincent Weiser. He is the Chief Ecosystem Officer for Molecule and AthenaDAO and one of the first supporters of AthenaDAO. He's a very passionate person in the world of decentralized science, and he's very interested in pushing anything that pushes humanity forward. So very glad to have him here. Vincent, the stage is yours.
Awesome. Thank you so much, Laura, for inviting me. And first of all, big congratulations to this amazing second research project with AthenaDAO. Very exciting to see it taking shape and affecting, hopefully soon, real lives with this first step. And yeah, like kind of to take a step back also with our work that we do with Molecule as well as BioXYZ, the goal is really to reduce the kind of friction for patients and scientists and people that are excited about science to make impactful research happening, like in women's health research, like Josh's amazing research project, and really to build mechanisms that enable this in a new and decentralized way. Of course, in this broader theme that most of you are probably aware of now with decentralized science and BioDAOs. And with Molecule, kind of Paul and Tyler, who founded Molecule early on, experimented a lot with different ways to enable the funding of research, like similar to crowdfunding platforms. And then I think the experiment that clicked the first really was AthenaDAO with as a biotech DAO with IP-NFTs. And I think also where the journey started for people like Laura and others in the community with AthenaDAO. So it's extremely exciting to see this amazing DAO taking shape over the last few years and now really starting to be able to fund the first research and advance the first research project. And I just want to on a high level highlight a bit how the IP-NFT and BioDAOs like AthenaDAO work. And I think the simplest way to visualize it is that the goal is really to make the underlying sponsored research agreement and kind of the attached rights to the research fully digital and tokenize them through an IP-NFT that communities like AthenaDAO can, as a collective, fund research and hold the research as well as advance the research over time. And the goal is really to make it as simple as possible by enabling many people to join AthenaDAO and then have the community of amazing researchers within AthenaDAO figure out like what are the most impactful research projects in women's health research, and which ones of those should we fund first, like Josh's project. And I think it really is a testament more to the community that is making this possible, like to the community of researchers, of patients that are excited about this, that come together around the cause and then really make it happening by contributing their resources, contributing their time to AthenaDAO, and thus making novel research happening that otherwise might not have the same dedication or funding. And I can, even if there is like 1 minute, I can just briefly share like one slide that might help to display kind of the visual, like as a visual, the IP-NFT. So it ultimately is composed of a sponsored research agreement, a legal contract that then gets minted as an NFT and then ultimately distributed to, for example, AthenaDAO. And this membership agreement can contain, of course, the different legal agreements, but also over time have additional data uploaded, and kind of it becomes like a living artifact, similar to how a company or how a DAO is a living artifact as well. So, for example, what happened now with AthenaDAO is that AthenaDAO decided and voted on actually creating the first community just around a single research project through IP tokens, which is a way to basically turn this research project into many pieces, which the community can crowdfund and own. And I think that's like the kind of the natural evolution that basically people can get behind individual research projects, for example, in AthenaDAO, like Josh, and say at a later point, like there's so many amazing research projects in AthenaDAO, I want to fund all of them through becoming an AthenaDAO member. And additionally, I might be very excited about specific projects that I put my money into. So that's more like to give some visuals and some high level ideas. And yeah, thanks so much for inviting me to this awesome occasion, Laura and Ines, and back to you.
Thank you so much for that, Vincent. We were very lucky that you had that visual for us, actually. And I think we'd love to have you as a guest eventually on the Discord server to take people over all of this. We've had questions about the IP-NFTs and how they work. And I think it's a very interesting model. We talked about a lot about it. And every time we talk to new funders, we tell them about how powerful a tool it is. Hopefully in the future, we're at the first stage. In the future, we'll be also doing our IP fractionalization when some of these projects come into meeting their milestones, which is very exciting, the promise of going from the sponsor research to potentially a molecule. Well, that's why the name is Molecule. With that said, thanks again, Vincent, for being here. I'm so happy that everybody can see me in Berlin with my big face in the new space that you guys have. With that said, even as you could bring up the IP, anybody who's curious to learn more about Molecule and the IP-NFT framework, and obviously who wants to see our actual IP-NFTs, they can head over to molecule.to and look for our IP-NFTs and the other NFTs that are in other areas of science, such as VitaDAO, ValleyDAO, and HairDAO, the other members of the BioXYC family. I also want to take a minute to talk about the artwork. We're very proud on our first series of IP-NFTs on ovarian aging to have Hannah Salmowitz be the artist. She is an aging biologist, and she also does these beautiful sculptures and artwork on her quote-unquote free time. And we have an entire series from her. So thank you again, Hannah, for this incredible artwork to illustrate science so beautifully. And the next part, as we're coming to the end of this live stream, is going to be about some of the projects that we have coming up for fall, winter 23-24. So as I mentioned, we already launched our tokens, so the governance is happening imminently. After that, we're also having a pitch competition, and you're going to hear more about that on the following days and weeks. We're launching our merch collection. And later in the winter and early next year, we're probably going to announcing the stealth company that we're working on. The other aspect is to remind you that we also are unlocking token utility. So we are going to be bringing a lot of experts, a lot of very well-known researchers and academics to our community. And I'm very happy and proud to announce that one of the first people that we're going to be having on a special session is, I'm going into a twist here. Dr. Dina Emera. She is an evolutionary geneticist, and she just published this book, The Brief History of the Female Body, very recently, and we are going to have a Women's Health Authors Club, which will kick off with her later in November. If you're curious about anything of this, please look on our website. You can join us on our Discord or on Twitter. I also want to remind you that we publish 2 public goods or reproductive health reports. There's a QR code that takes you to the pages that has both the Reproductive Biology Today on Ovarian Aging and our PCOS and endometriosis reproductive health report. We are already working on a 3rd one. Any researcher scientist who is touching oncology or cancers, we are looking for obviously contributors to our next reproductive health report. Lastly, as a reminder, we are an open community, and we are always looking for new members to join, either as a contributor, as a member, as a researcher, as a woman, as a patient, a man that wants to support women's health. Anybody is welcome. If you want to know more about how we can change the future of women's health, please join us on our mission. And the QR code for our Discord is there, but we're also on a website. You can email us, or you can always follow what we're doing on Twitter and Instagram at AthenaDAO. Again, thank you so much for everybody who joined us today. Thank you to Dr. Joshua Johnson for entrusting us with this. Inez for powering this, Maria, the Deal Flow team, Comms and Awareness, everybody who's contributed to this, and to all our partners and friends, Molecule, BioXYC, and our family in the DeSci ecosystem. Until the next one, and hopefully we'll be very soon. Thanks.